Sorry for being a bit late. I was flying. I flew here with the landing gear down because it was like some kind of landing gear issue.
Landing gear was stuck?
There's some kind of warning light, and my pilot said that if they retracted the landing gear, it may not go back down again. So I thought
this
probably
happens,
best to leave
this
it down.
even happens to you?
Yeah.
Yeah.
Okay.
Had landing gear problems of various kinds.
Anyway, we're happy to wait for you, and we're glad you got here safe.
Well, thanks for having me. It's great to see you guys.
Thank you for coming. I really appreciate it. You kept your promise, which was nice.
Of course.
I think you were drunk when you promised me, but that's okay. I'll take it. So, in the couple of years since you've come, you've done some astonishing things in terms of substantive stuff with both your companies. Let's start talking about space and what you've been doing there. Obviously, you've had some success landing the rocket. You've done a bunch of other things where people thought you weren't going to be successful. Talk a little bit about sort of the progress you think you've made with SpaceX.
Sure. Well, I mean, there's a lot of things where I think I didn't think we'd be successful. So probably and the most significant thing is being able to land an orbit class rocket boost stage and bring it both back to Cape Canaveral, land on land, and be able to land on a drone ship out in the ocean. There is a bit of an education process that's needed to understand orbital dynamics, because a lot of people are confused of like, why the heck are you landing a rocket on a ship in the ocean? That seems pretty inconvenient. And the reason is because that going up and staying up is actually about velocity horizontal to the Earth's surface. So there's a huge difference between space and orbit. Like space, you could think of as like, say, being the international waters boundary for the Pacific Ocean. Like if you go, 100 miles offshore, you're technically out of coastal waters. Now you're in the Pacific.
Right.
So it's like technically you're in the Pacific, but orbit is like circumnavigating the globe. Right. It's a really giant difference. And the reason that things go up and stay up is because you're zooming around the Earth so fast that your outward radial acceleration is equal to the inward acceleration of gravity. And so those balance out, and you have a net zero gravity. So when you see the space station, the thing that's a little sort of counterintuitive is that the space station is actually zooming around the Earth at 17,000 miles an hour.
Even though it seems like it just...
It seems really still, but it's moving really, really fast. To put that into perspective, a bullet from a .45 gun, handgun, is just below the speed of sound. So the space station is going more than 25 times faster than that. And that's what's needed actually to go up and stay up. And that's why there's the term escape velocity, not escape altitude. There's no such thing as an escape altitude. There's only an escape velocity.
You need to be a certain speed to escape the gravity of the Earth.
Yeah, you can think of gravity as kind of a funnel in space-time. Or think of like a coin funnel. Like it's very much like that but it's obviously sort of a four-dimensional coin funnel. But if you spin a marble or a coin on a coin funnel, when it's far out, it sort of spins slowly, and then as it gets closer, it spins faster and faster. And if you were to start at the bottom of the coin funnel and you wanted to exit, you'd spin it horizontally, and it would spin out, and that's really how you get to orbit. So
how does
the
that
gravity
relate
well
to
is like a funnel.
Why you want to land on a ship in the ocean?
Because in order to get to orbit, all that matters is your horizontal velocity. Your altitude doesn't really matter. In fact, the force of gravity at say the sort of nominal boundary of space, 100 kilometers, is almost exactly the same as it is on the surface of the Earth. It's like if it's a few percent lower than the surface of the Earth. So in order to go up and stay up, the only thing that matters is how fast are you going horizontal to the Earth's surface. So you have that outward radial acceleration, or think of it maybe like tetherball or something like that. It's really that outward acceleration is the thing that matters. And so when the rocket is going to orbit, The only reason it's going up is to get out of the thick part of the atmosphere. Because at high velocity, the atmosphere is thick as molasses. And so it goes up very briefly, but if you look at a long exposure of the rocket's trajectory, you'll see it goes up, but immediately curves over and starts going horizontal. And so at the point at which the point at which the stages separate, those two stages, the primary boost stage, which is the most expensive part of the rocket, the point at which that staging occurs can be as high as Mach 10. But it's going away from the launch site at 10 times the speed of sound. So in order to get back to the launch site, you would have to have enough fuel and oxygen to reverse out that velocity and boost back all the way to the launch site. And you just don't have, the physics of it don't really allow you to have that much. It's not about saving money on fuel or anything, it's just physically impossible. Because another sort of thing about if you're in space is that there's nothing to react against. So, like whereas an aircraft can circle very easily because it's reacting against air, in vacuum there's nothing to react against. So the only way to go back the other direction is to apply just as much energy as it took you to go. If you want to go backwards, you have to apply just as much energy as it took you to go forwards. Mm-hmm. In fact, well, twice as much, really, because you've got to zero it out, and then you've got to...
So you've got to land elsewhere.
Yeah, so bottom line is this thing is zinging out to sea at 10 times faster than a bullet.
At that point, it may well be over the ocean, because the ocean covers most of the...
Oh, it's actually, at the point of separation, it's not that far away. It's maybe 100 kilometers away from the launch site, but it is going like hell in the opposite, away from the launch site. So the only way to really land it is to have it continue on that arc, that ballistic arc, and then land far out to sea on a ship that's pre-positioned to a particular latitude and longitude, very, very precise, to within about a meter. And then the rocket will then go from vacuum through rarefied air at hypersonic velocity. So when it's in vacuum, it has to, obviously you can't use aero surfaces. You have to use nitrogen jets to control the attitude and position. And then as it starts to encounter the air, we use grid fins, because grid fins look like sort of like a waffle. They work quite well across a wide regime, from both very high velocity hypersonics through supersonic, transonic, and subsonic. So it's hard to have aero surfaces that work well across that entire regime. And then, so once the aero forces become high, it uses the four grid fins to sort of control its attitude.
To land itself.
Yeah, it's controlling it's controlling pitch, yaw, and roll with the grid fins. And then those grid fins will then position it to where it's fairly close to the ship, and then it will light, in this case, 3 of the 9 engines to arrest the velocity, and then drop to 1 engine for precision right before landing.
Right. Okay.
So
super
that was
hard.
maybe a bit of a long explanation.
No, that's okay. But okay, what we're going to get to is that's super fucking hard.
There's a video.
So why is that important? Why has this moment been important for you?
Well, so in order to reuse the boost stage, which is about 70% of the cost of the rocket. So
which cost is that? How much is that?
Well, I mean, it's sort of on the order of $30 to $35 million.
Right. So you want to save that.
Yeah, I mean, it's like I tell my team, it's like imagine there was a pallet of cash that was plummeting through the atmosphere, and it was going to burn up and smash into tiny pieces. Would you try to save it?
Right.
Probably yes.
Yes. Okay.
Yeah, that sounds like a good idea.
Right. Okay.
So we want to get it back, and that way we don't have to make another one.
Right.
And
I think it's quite tragic if rockets get smashed into tiny pieces and land at the
So
bottom of the
can
ocean.
I ask a question? We've been going to space for what, 50 years or something like that?
Yeah.
Nobody, until you started doing this and Jeff Bezos' company has done it, the government never
They're
sort
like
of
different
saved the
things, but
rockets.
yeah.
They never saved the pallet of cash. Why not? And the Russians didn't either. I mean, what was the deal there?
Yeah, I mean, there was some attempt made to do that with the space shuttle, but there was no return. It's the first time that a rocket boost has returned to launch site
Right.
From an orbital mission, and certainly the first time that there's been a landing on a ship out
But
to
the
sea.
regular rockets that went up that weren't designed like planes never tried to do this.
Right. The plane thing is not a good idea in my view. The plane, and the reason I think is, like, intuitively it seems like a plane should work, but actually if you consider that really every mode of transport has a design that is appropriate to its medium. And if you're in space, wings are not very useful because there's no air. And then if you want to go somewhere other than Earth, there's also no runways. So these are important considerations. So that's why when they went to the moon, they used propulsive landing.
Right. But what I'm saying was when they built the space shuttle, it sort of was looked like a kind of bulbous
I think that appealed
plane.
to Congress. Yeah.
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 They went, cool, that's cool.
Yeah. It looked like an airplane.
Can you explain
Okay.
Jeff Bezos?
Good one.
Jeff Bezos was here last night, and I asked him, what's the difference between what you're doing and what Elon Musk is doing? And he said, well, I think we have, I think he used the word like-minded in the general sense of it, and then he went on to explain some differences. And then he talked about, and correct me if I'm misquoting him, but I think he was saying, this is all about laying the foundations of being able to do greater things by getting the basic infrastructure of being able to reuse these rockets down right. Is that correct? Do you have a similar starting point from him and your thinking process?
I mean, I think there's certainly some similarities of opinion. I think both Jeff and I believe that it's important for the future to be a spacefaring civilization and out there, ultimately be out there among the stars. And I think that's the exciting, inspiring future that I think certainly people in this room want, and anyone.
Well, particularly after seeing that the asteroids are going to destroy this planet. I mean,
I mean, I don't view it as I think when I say multi-planet species, like that's really what we want to be. It's not like still being a single planet species but moving planets. It's really being a multi-planet species and having civilization and life as we know it extend beyond Earth to the rest of the solar system and ultimately to other star systems. I think that's the thing. That's the future that's exciting and inspiring, and I think that's what I think you need things like that to be glad to wake up in the morning. Like life can't be just about solving problems. Like there have to be things that are inspiring and exciting that make you glad to be alive.
So what, in the immediate time frame, what is your goal for SpaceX now that you've done this, which is a huge accomplishment? What is the plan for you in the immediate time and then the longer range?
Sure. So so we plan to refly one of the landed rocket boosters, hopefully in about 2 or 3 months, something like that. And then so that'll be an important milestone. So far, the stages are looking like quite good, even though they come through quite. It's a really difficult re-entry situation, but they're looking like they're in good shape. And we now have 4 of them. So we want to start reflying them, towards the end of summer, and then hopefully. By the end of this year, we'll be launching Falcon Heavy, which will be the most powerful rocket in the world by more than a factor of 2. Mm-hmm. So Falcon Heavy will be on the order of 5 million pounds of thrust on liftoff, which is about 2/3 the size of a Saturn V.
Oh, really?
Yeah. So
that's the rocket that took the astronauts to the moon.
Right. Exactly.
So
in fact, we're launching from the same pad,
very same pad.
from the Apollo 11 pad.
Wow,
Yeah.
that's amazing. So you're
and
hoping to
yeah.
launch that Falcon Heavy by the end of this year, you said?
Yeah, that's our aspiration.
Is that, now that's somewhat of a delay from when you first hoped to launch it, right?
But I mean, it's not like we had a lot of pressing customers who wanted us to launch it.
Okay.
So in fact, the first launch will not have any operational satellites. It'll be a demonstration launch. And the first operational flights where customers actually want us to launch it are next year. Whereas there's a lot of customers who want us to launch Falcon 9. So about a quarter of our flights are for NASA, but 3/4 are for commercial satellites, like broadcast and communication satellites, or science missions for other countries. And there's quite a backlog. And we had an issue with the rocket last year, so that put about a 6-month hold in our schedule. So we're sort of backlogged on our launches, and we're trying to get them out as quickly as we can, and service our customers. The launches will take place, every 2 to 4 weeks. There's quite a high launch cadence.
That's a much faster cadence than NASA had, right?
Yeah, it'll be more launches than anything else in the world. So more than Russia, more than Europe, more than China by next year, certainly.
And largely to deliver customers' satellites.
Yeah, there's a lot of broadcast and communication satellites that are going to geosynchronous orbit, and then we'll also be launching the new Iridium constellation. So the Iridium's got a next generation constellation of satellites. I think 60 or 70 satellites, quite decent sized satellites. That'll be like many orders of magnitude improvement over the current Iridium system. So we'll be able to have global broadband. So that'll be a whole bunch of launches, and and then next year we'll be flying Dragon version 2, which is the one that's capable of taking up to 7 astronauts to the space station. And in fact, Dragon 2 really it's a propulsive lander as well, and it'll be it's intended to carry astronauts to the space station, but it's also capable of being a general science delivery platform to anywhere in the solar system. So,
so where are you going with it?
we're going to send one to Mars in 2018.
Okay. Now, let's talk about
Wait. 2018, that's for sure.
Yeah, a couple of years.
couple of years.
Okay.
Now, will you be on that flight?
No.
You have talked about this. You said you don't want to, you want to die on Mars, just not on landing, right? Is that correct?
Well, I mean, I think if you're going to choose a place to die, then Mars is probably, not a bad choice.
All right.
But you're not ready
It's not some sort of Martian death wish or something. But yeah, I mean, if you're going to be born on Earth, die on Mars.
So
sounds pretty
sending
good.
this up to Mars 2018, right? Sending this up to Mars 2018, when will someone like you get there from your plans?
Sure. So the 2018 mission would be our Dragon version 2,
Right.
And that I wouldn't recommend traveling to Mars in that, because I mean it has the interior volume of a large SUV.
Okay.
And the trip for Dragon would be on the order of 6 months. It's a long time to spend in an SUV, I think. So it can be done, but probably not ideal. And it also doesn't have the capability of getting back to Earth.
Right.
That seems more important than the space.
Yeah, we can put that in the fine print.
Yeah.
Sorry.
Yeah.
I'm gonna take it.
It's like the side effects in a
Yeah.
drug ad.
By the way,
We
yeah.
Cannot get back to Earth.
Yeah.
Yeah, we saw the movie. We
Yeah.
saw what happened. He got back.
Yeah, yeah. So it was good. I actually enjoyed the movie. So.
Do you think he could have gotten back like that? Was that plausible?
Well, I thought there was some connection. It was like 80% scientifically correct. But there did connect a series of improbable events.
Such as?
Say. Well, I mean, I don't think you can sort of just take off from Mars on an unguided rocket, really, and then prick your finger on the spacesuit and navigate to a spaceship. Right? Yeah. Not impossible, just extremely unlikely.
So the Sandra
But if
Bullock
you're
movie.
but if you're Matt Damon, maybe.
Maybe. You have some mad skills,
Yeah,
for
yeah.
sure.
So when will people like yourself get there? And I assume you'll be first in line for that.
Yeah, so later this year in September at the IAC, which is the big sort of world space conference, industry space conference, I'm going to be presenting the architecture for Mars colonization. So I think what really matters is being able to transport large numbers of people and ultimately millions of tons of cargo to Mars. And that's what's necessary in order to create a self-sustaining, not really self-sustaining, but a growing city on Mars.
So I'm curious, have you been to space yet?
No.
Why? I mean, you could just go up, right, for a little bit, or not?
I could, I suppose. Yeah.
No? Why haven't you? Like
I
walked
think I
around
will
the
at some
moon or
point.
something, or
Yeah, well, yeah, probably will.
will you do a moon test
well.
before you go to Mars?
Yeah, I mean, I'll probably, I don't know, go to orbit in 4 or 5 years or something like that.
But-
again, space and orbit are very different things. Yeah.
But on the Mars thing, would you send up 2 or 3, whether it's you or not? I kind of would prefer it if you tried it, frankly, but
Sure.
because it would be exciting. But would you send up some people before you do this whole architecture for colonizing Mars? Just a handful of people to kind of
Well,
see what.
I mean, the basic game plan is like we're going to send a mission to Mars with every Mars opportunity from 2018 onwards. So, and they occur approximately every 26 months. So, you know, we're establishing cargo flights to Mars that people can count on for cargo. And it's like I said, the Earth-Mars orbital rendezvous is only every 26 months. So there's one in 2018, there'll be another one in 2020. And I think if things go according to plan, we should be able to launch people probably in 2024 with arrival in 2025.
Soon.
Is that a more certain schedule than United Airlines?
Well, I don't know.
Well, he hasn't
There's
been on
certainly some
United
uncertainties
Airlines for
associated with
years.
that.
So let's. I'm going to shift.
Anyway, that's the game plan. Like approximately 2024 to do the first to launch the first of the Mars
And
colonial transport system.
I
with
want to get
people.
back to what you said earlier about a multi.
This will be a very big rocket.
Okay, very big, bigger than
Very
the
big.
Saturn V.
Yes,
Twice as big, or what?
September. I'll tell you.
Not going to say anything till September? Come on,
Very big.
come on.
Has to be very big.
How big is very big?
So big.
Do you think we should abandon the Earth at some point?
No, I think that's great.
But you have said things.
Why would we abandon Earth? It's really nice here.
You've said things about we may have to abandon the Earth, so it's good to have a plan B. You've said
No, I
that
haven't.
before.
No, that was Bezos.
I think that's
Bezos.
maybe I don't know, but it wasn't me.
All right. Okay.
It wasn't me, like Shaggy.
Right. So let's move to things on this Earth. Let's move to Hyperloop, Tesla, other things. But let's talk about Tesla first.
Sure.
Where do you feel like the company is at this point? And there's been lots of activity in self-driving cars, in autonomous, semi-autonomous. How do you look at how everybody's jumped in? Google, Apple, others, and all the car manufacturers.
Yeah, I mean, there have been so many announcements of like autonomous EV startups. I'm waiting for my mom to announce one.
Okay.
It's like, Mom, you too. I mean, there's a lot. So, yeah, I mean, in the U.S. alone, there are 4, I think maybe 5 China-funded EV startups.
Mm-hmm. Yes, there are.
At the $1 billion plus level, like serious funding. And there's a bunch of startups, and then of course the car industry as a whole seems to be moving in that direction. Volkswagen just, I think, announced a huge battery factory that they're going to build. And I think these are all good. It's good for the industry to be moving towards sustainable transport as quickly as possible. We open sourced our patents to try to be helpful in that regard. And yeah, so it's encouraging to see all this activity. From a Tesla standpoint, we're just we want to take a set of actions that are likely to accelerate the advent of sustainable energy. Scale up production as fast as we can. So we accelerated plans for the Model 3 by 2 years. And so we want to try to get to 500,000 cars in total in kind of the 2018 timeframe, which is an aggressive schedule, but I think achievable. And then maybe 1 million cars a year by 2020. I can see I think a pretty clear path to get there. Autonomy is obviously extremely important. People are going to want autonomy. It's going to be odd to have a car without autonomy in the future. Yeah, so I think that's.
So what do you,
scaling up.
How do you look at all these efforts? Not your mother, but
yeah, my mom's. Yeah,
she's not going to do it. She may do a rocket situation, but how do you look at each of them? Let's go through them. What Google is doing. How do you assess what they're doing when you're looking at it? Because there'll be competitors at some point. These are all eventual competitors.
Well, I think what Google's done a great job of showing the potential of autonomous transport.
Right.
But they're not a car company, so they would potentially license their technology to other car companies. And I think they announced something with Fiat. So I wouldn't say Google's a competitor because they're not a car company. We would compete with somebody perhaps that they license technology to, but not to them directly.
Right.
Apple?
Yeah, that'll be more direct.
That'll be more direct?
Yeah.
You can tell that by the hiring pattern and that
absolutely.
kind of stuff? Yeah. So what do you, okay, so they're going to be more direct. How do you assess it?
I say I think it's great that they're doing this, and I hope it works out.
What's the time frame for them, do you think?
I don't know. I think they should have embarked upon this project sooner, actually. But I don't know. I don't know when they. They don't share with me the details of their production plans. But I don't think it's going to be. I don't think they'll be in volume production sooner than maybe 2020. That'll be like the soonest.
And is that too late? When you say they should have embarked sooner, is that because 2020 will be too late to stop you or beat you or compete with you or what?
No, it's just like it's a missed opportunity. It's just
It'll be over by 2020?
No, it's not. It's just like it's a couple of years. I think they'll probably make a good car and probably be successful. The car industry is very big, so